Hello, it's James from XRobots.co.uk. This is part 12 of my life-size Ultron build, which is going to be a real robot. Here it is. I've done quite a lot already. There's quite a lot of 3D printing in there, as you can see. And I've implemented 2 shoulder axes already, which I did last time and in the episode before. So it's really important to check out part 3, where I built this little test arm. And I drove it from a motion capture sensor, and in the earlier parts I built a motion capture suit. So the aim of this robot is it's going to be driven by partly motion capture, partly working out what to do with limbs that aren't driven by motion capture. It's also going to be driven by its own AI. In part 4 I built this other test arm, which is to test series elastic actuators, so it's actually going to have force feedback on the joints, and that's what's inside these hubs that I built. So that's another really interesting episode to check out, the early R&D I did before I started building the actual robot. I'm going to pretty much carry on from where I left off in the last part, but check that one out to see it actually almost in motion. And today we're going to do some more mechanical design and get some more parts made, probably for the neck assembly and some of the stuff that holds the cosmetics on. Here's the overall view of Ultron. So this is partly what's been made already, the lower body there. Some of the mechanics, the shoulder hubs here are kind of the crude basic versions, but they're pretty much that shape. And we've also got the gears in the front there. If I just hide these pieces, these are the gears that I made last time. So on the whole, this is the whole layout. What I haven't designed yet is the top part, so these neck sections and the shoulders here. And obviously with the arms on, there are big shoulder bells that go over these green pieces and over the shoulders. So at the moment it looks like that the neck's very long and the head's very tall. As far as I can say, based on where the shoulder pivots are, this is proportionally correct. And I've looked at quite a lot of reference images from the movie and the Hot Toys figure and so on and so on. Obviously the head is a crude representation, and these top green parts are just there for scaling really. So the next thing I need to do is build a proper kind of neck section, but we also need to support the chest here, and we also need to support the back here, the shoulder blades, and those pieces are going to need to flex as this big blue piece hinges around, and that goes around front to back. So the shoulder blades really are going to need to be on a flexible pivot, probably attached down the spine, which I haven't designed either yet. Same with these shoulders, the shoulder bells and everything, they need to go up and down and all around. The neck itself won't be a massive block, that's just there to get scaling, so that's going to be another mechanical assembly that allows the head to rotate and also kind of pan and tilt. So I want to build some hybrid parts there with some Ninja Flex parts and bits and pieces that can flex around, those sort of big cables that come down the front of the neck there. I've also got to build in the clavicle, which hinges on this point. But again, because of this blue thing rotating round, that needs to be able to move backwards and forwards off centre from its own pivot and move up and down. Or maybe I can build it on centre with the pivot, and the pivot point is here. Otherwise the other end is just going to stick through a big hoop, I think, so that it can move all around and have a flexible joint at this end. I also want to be able to mount the chest on that same piece that's mounted on top of this blue bracket holding the neck and the head up to hold these panels on, because at the moment everything is floating there. And there's nowhere, nothing's really attached, it's really just there for scaling. Of course there's more surface detail and the breastbone to go in, but I'm not going to even think about the cosmetics till I've got that other. Basically it's a big piece of core mechanics that bridges from the back all the way over to the chest holding the head up. Then after that in the future we can start thinking about putting the arms on. A crucial part of this is getting the head rotation and panning and tilting correct. So obviously the head needs to rotate. Probably at least, well, not quite a 180. Can I do a 180? Almost. So it needs to rotate, but it also needs to be able to look up and down and look left and right. So it's actually really similar to my BB-8 build. So in terms of the axis, there's obviously 3 things there, which is going to need at least 3 motors. Here it is, and if you haven't checked out that series, it's in my channel. But basically what we have is a head that can rotate, and it also can move all the way round, and the way it does that is by having a servo right in the middle that rotates it. You can just about sort of see it, it's hidden in that central column. And then we've got a servo either side, so there's one here and there's also one on this side, and they push rods in a triangle to this thing so it can move all around. So I'm going to take the same approach with Ultron, probably using similar servos, at least these. The rotation is going to have quite a lot more force on it around this column. At the moment there's a servo in here, but I don't want to do that with Ultron. I want to have a proper geared motor mechanism, because it's going to have to pull those flexible cables, like conduit things, down the front of its neck around. But I probably will use the same servos here at a different leverage angle to pan and tilt the head. If we imagine that this coffee pot is a rotating tower that the head is sat on top of, so let's just say that this is the head mounting platform for now. So obviously as it rotates, the head rotates, but we also need to pan and tilt. So we need two actuators stuck somewhere, probably either at the front or the back. I think I'm going to put them at the front. So those will be the servos that push up and down. So that means obviously if they both push up, the head pushes up and down. And if one pushes up, it can pan and tilt like that. I could put them one at the front to push up and down, and one at the side to push up and down to do it that way. But I think I'm going to put them both at the front because that's kind of how Ultron looks with those two conduits or whatever that run down the front. The issue is, of course, with these attached, if this then rotates, these have to lean over and they probably need to get longer as well, which means they're then out of reach to move the head up and down because they're already extended to reach around this angle to move the head up and down here. So what probably has to happen is that these have to rotate around with it so they're still straight and then they can pan and tilt. So that's quite a big consideration. They're probably going to be stuck in more like this, a bit more like Johnny Five's head, and rotate around the same base. So that's quite a consideration before building it. That means having one big rotational column in the middle that's strong enough to support all of this without wobbling. In terms of motor choice for rotating, what I've previously used in the build, apart from the big linear actuators, were these motors that are 300 RPM, and they go quite quick. So the reason for that was that I didn't want lots of load on this shaft, so I could have just used a motor that was geared down much more, but then most of the torque, most of the load would be directly on the motor shaft. So what I did instead was have this go quite quick, so there's not so much torque or so much load on the shaft, and then have lots of plastic gears that take the load and gear it down, and those are all mounted on bearings. And that means it can move the heavy load of the arms and lifting the torso, and the motor can go really quick without much load, and the rest of the load is on the gears. For the head that's slightly different because there isn't much torque required. No one's going to force that head to turn back the other way. It's hopefully not going to get jammed on anything, and it's going to be relatively light, so it makes much more sense just to use a motor that's geared down instead of printing my own gear train. So I'm going to be using this, which is a Como Drills 919D, and it's an 810:1 motor, and it already runs practically at the right speed. So if I just stick this clip on top, should be able to see how fast that goes. It's a fairly hefty motor, so it'll be able to turn the thing precisely, but it's already geared down quite a bit. So I'll probably take that down to not even a 2:1 to turn the output head shaft. If we put this onto this one, I can show you the difference. So this would need considerable extra gearing. So that's what's driving the arms back to front, which is why I didn't put the whole output on the motor shaft. Obviously it's too fast, and I did have an extra gear train, but I think for the head this will be fine, and it'll be to move it really precisely and under control. Here are my gears which I'm going to use to turn the neck. So the smallest one is 14 tooth and the biggest one is 20 tooth. And the small one here, you know, it's got this captive nut again, so I can put a bolt in to hold it on the flat on the shaft, and that should give me just under a 2:1 ratio. So I'm going a bit slower but not too slow, and obviously the bigger one is going to drive the neck around in its rotational axis. If we then look at those positions, I've got some 8mm studding there, so I've got the bigger gears now got this column on. On the top of the column is going to be mounted the pan and tilt axis for the head, and obviously this thing is mounted on bearings, so I've got the extra large hole there for a bearing each side, and it's on this piece of 8mm studding. The motor bracket I've got here is for that motor I showed you. I've left holes in it there because the motor has vents in to vent air, although I'm not expecting it to get terribly hot, and that's going to be mounted at the bottom there onto a block which holds the bottom of the studding, so that'll be part of the bracket that goes from the front to the back to hold the chest plate on and so on. So I still need to design that assembly, but that's roughly the right orientation. And the motor shaft is off centre, so I've positioned this back slightly, but I'll probably allow a gap so I can put a shim in there to get the motor bracket exactly the right distance and get these gears exactly the right distance, given the issues that I had last time. And I think I've positioned them correctly, but I'd still like that lenience to be able to move it. So the next thing is to put the servos in, which is a bit of a challenge. So they're quite big servos, and if they rotate around with this whole thing stuck on the front, as I explained, that's going to cause me some issues. I've just put the shoulders right in their most upright position, so I've extended the linear actuators without extending the ab actuators. Obviously it can only reach further if it leans to one side. So obviously we're quite constrained in the middle here by this assembly, and the distance I've got in there, to stick a ruler in, is sort of 90mm absolute max. So that's fine, because the servos would have to be stuck on the front, so the shafts come up to the front of the chin. And I can have, you know, either bendy or slightly curved push rods to push the pan and tilt mechanism on top of the head. The problem is, of course, when the head turns, those servos will just hit the sides here if the arms are up, so it wouldn't be able to turn its head with the arms up. So although I've got the kind of advantage of the increased leverage angle with all this, it's restricted what I can put in this head column. So I think what I'm actually going to do is put the servos stationary, have bendy push rods or curved push rods, and then the middle will be able to turn, and we'll just have to extend those servos to their maximum as it turns, which is going to restrict how much it can look up when its head's turned to one side, but I'm not really seeing that as being a major issue. Here's that whole assembly, obviously with the servos mounted stationary at the front, and they are mounted quite a bit further forward, so I get some proper leverage there. So I've made this T section essentially out of the yellow and red brackets, so that's nice and strong, and that can be extended forward to mount the chest plate on. You'll notice I've left a gap here with the motor bracket so I can put a shim in exactly the right length and fine tune that gear distance. But basically the piece of studding goes all the way through the bracket and out of the bottom. There's space for a captive nut in the bottom, so that should hold it nice and rigid and allow the neck to rotate around on top of it, and that's M8 studding. So putting that back into the assembly, I've extended forward the bracket here so that it holds the chest plate. So that mounts quite nicely. Haven't quite decided exactly what happens yet, but obviously those chest sections and the breastbone will mount on the front of this. It should be strong enough because it's a T section. I've cut out places for the two motors to fit that are already there. There is space to put some more stuff below to give that extra strength if I need to, but I think it's going to be okay. And this mounts onto the blue bracket that's already there. I've left a couple of screw holes spare at the back so we can mount that spine on there, which is obviously going to be a separate piece, but on the whole that seems to fit in pretty well. So extracting that, these are all the pieces that need printing, and this is it together. So that's the whole assembly with the front on, and then we split that up, so the red part needs to be split into two so it fits on the print bed. The silver part here, the main drive gear, needs to have that pan and tilt assembly put on top, but that can always be solvent welded on, so I'm probably going to print this, insert the bearings, check all the gears work before we work our way up the rest of the head. And I've split the yellow part in two there, and I've put this hole in the middle so we've got space to run wires through from the two motors. So let's get that printing. Hopefully we should be able to assemble it and have it running. Here are the parts all printed out. I've already attached these together and these two pieces back to back, of course, so this now fits in here like so, and this piece goes along the top to mount my servos in each side. So I've got my thing here with its bearings attached, which fits on there, and I've put my motor into its bracket there, so that will screw on the back, and I left a slight hole there so the bottom of the motor can fit down. And obviously this gear goes on the motor and meshes with this. So I just need to put some screws in here and put the piece of 8mm studding in so I can mount the actual neck rotation. We should be able to give this motor a spin. Most of that is together, so I've got this piece on here and I just need to fit the motor on. So what I found is if I take the motor bracket off and I take the shroud off, and I put the motor straight in the bracket, then as with the other motors, the shaft is off centre, so I can turn this whole thing around. And I can move this shaft backwards and forwards to get the spacing exactly right, so I can screw that straight on there and then just rotate that and clamp it in place, and that gives me exactly the right spacing between those gears, which is about there. So let me get that screwed on and we'll power it up. Right, it's together, so the motor's mounted on there pretty well, and if I soldered some wires to it, so if I just give this a spin, obviously we can see that works pretty well. So obviously it'll be PID controlled, speed controlled and position controlled, but I think that's, for turning the head a little bit, is probably just about the right speed of rotation. So now I'm going to screw this on the rest of the robot and we can see what's next. Alright, here it is fitted, so it feels just like I want to attach that chest plate to it, but I really need to concentrate on the mechanics and not get carried away with cosmetics right now. But it's feeling like it's getting fleshed out, and you can see where things are going to fit and how it's going to be scaled. So now I'm going to have a look at this spine and have a look at how those shoulder blades are going to attach. This is what we've got at the spine here. So I had this red thing that supports this top platform, which is attached to the plate that leans. And we've got some screw holes at the top here, so I can easily make a piece here that's got those shoulder blades on that hinge backwards and forwards as the arms move. So I just need to design really quite a simple hinge, I think, that I can mount those on, but still allow space for a static spine. And of course that spine runs all the way up to the back of the head there to kind of have conduits that go up into the back of the skull, as it were. So I just need to make sure I leave some clearance for those things. So it's probably 2 independent hinges each side. Looking at the model again, I think what I probably actually need to do is keep that pivoting thing right down at the bottom of the spine, essentially, at the bottom of this red thing. So the shoulder blades and things here need to, of course, pivot out with this blue part and move around with it. So I left some screw holes in there for mounting the other end, which is going to have to be some sort of sliding assembly. So obviously as this piece moves in and out in this axis, then these have to follow it, but also as the blue thing hinges round back to front, they have to follow it as well. So what I need, I think, is some universal joint right at the bottom of this piece, hanging at the back of these. And bear in mind, these are just the crude details. They need fleshing out so they can have mechanics built into the back and so on. And they also need attaching together and some other pieces in between them and turning into big pieces. That'll come when I do the cosmetics though. So I think a 2-axis hinge is what I need, so they can hinge kind of back to front and also side to side. So I think that looks something like this. So that's that red piece, and I've just put this piece on the bottom which will be solvent welded on, and that'll have 2 axes that run through it, and then I'll have another one that runs front to back through these blocks. So it's sort of almost a universal joint, but it doesn't allow for the extra axis of twist. And I thought about using Ninja Flex for this, which would allow the same thing without any hinges, but of course that would allow all 3 axes to bend, and that means those pieces will be able to twist and bend in the other axis, which is undesirable. So for now those are going to be mechanical pieces, and they're pretty simple really. It's the other end where the magic will happen, but as I say, that'll probably be some sort of slider or a hoop with a stick through that can move in multiple axes. Here it is. So I've decided to turn these pieces inwards so that they fit in the small of the back here, and as this plate tilts sideways it doesn't hit on here, but I can get them right in. So we're going to end up with another shaft through this way, so that when this folds in we've still got a pivot point that allows this to pivot backwards, or a plate that comes in this way to actually pivot the back of that. It's been quite tricky, in fact, to get the angles right and make sure it avoids everything else and make sure it's further enough in. So I'm not going to stick this on for now. I'll probably do that when I come to do the shoulder blades and the other cosmetic parts. But it's really good to be able to think through how this is going to work and kind of solve the problems as I go. But let's have another look round the front. I need to check for any other mechanical issues. So one thing is, of course, this chest plate, which is going to be one of the next pieces to actually get made, and it mounts on that bracket I made. I need to check when this comes round it doesn't hit whatever I finally designed. So if we go and use the Smart Rotate feature here, and we rotate around that face, which is the rotational point of everything, and I rotate the assemblies, and let's just do this. we can rotate this piece round. Now at the moment it rotates round, and I think it's about 33 degrees, which is roughly when it hits this gear down at the bottom. So I don't want to go too close to that because obviously it turns, and it just touches that bracket I've made at the same point, so I just need to check. Let's just hide that we don't run. Okay, we only just run into the chest pieces, so that's not major. That can skinny down. That will probably skinny down a bit so that I can use the hole in the front of the clavicle thing there to put the clavicle on, and that's probably just going to rest on a saddle on that yellow part. And it's actually going to go around this face of the thing, so that's going to be okay. So let's just put that back. So I do need to probably skinny down the back of this by a bit in some places, but obviously not where it's bonded to that bracket, so I probably need to take maybe 10mm off there and just put that clearance in so I can use the hole in the end. So that's all going to be fine, and I think that's good. So I need to put some surface detail on these chest pieces before I can actually print them, and I'd like to get some of these cosmetics attached next. So obviously these are curved surfaces, but I need to cut it up basically and pull some bits in and out, and you can't draw a sketch on a curved surface in here, so I need to cheat slightly by going and getting, say, another block, and let's snap it onto there. There we go, and we'll just make that slightly smaller, and that gives us a flat face to draw detail on. So the way I'm going to do this is by drawing lines on here, some sketches. Let's just draw 2 lines on that plane there. There we go. Now we can delete the block and we've got some lines, and we can basically split that solid now using those. There we go, and then we've got a surface there we can pull in and out. So I can pull that piece out in like that. That gives me a recess, and then I can merge it all back together again. And that leaves me with some surface detail. So I need to go and look at reference images and try and work out what to do with these. And hopefully we can get these stuck on as well, and then it's really starting to take shape. Right, so I've added quite a bit of detail to those. It's not exactly movie accurate. If you've got reference pictures and put them next to it, it's in fact completely different. But it's mostly sort of, you know, looks a bit like Ultron. So there we go, and I think I can print these things in one piece, but I need to do something about some of these overhangs. So if I put this top edge flat on the print bed, then obviously we've got some sort of completely horizontal overhangs that I need to deal with. So I've taken these further and stripped them out, and then I've put chamfers on all the edge, so all of the overhangs kind of lean out at 45 degrees, which I know I can print fine. And if they don't, like these pieces here, then they're a bridge between 2 pieces that do. So I think everything on there should print okay. Slicer seems to think it can do it without support material. Let's just have a look at the preview. So that should be the whole thing. I'm doing 15% infill because I don't want them to be very heavy, but the entire thing should build up okay in one piece. And that part is yeah, 246mm tool, so just a little bit to spare inside the build height of the Taz. Here they are, they've come out pretty well on the whole for ABS prints in one big piece. There's a slight split in this one, but the other one's fine. So pretty happy with that. Obviously they go the other way up and they get mounted onto Ultron. Here they are, they mounted on pretty well. I've just stuck those on with some double-sided tape for now because I probably want to remove them eventually to get to the things underneath so that I can put the series elastic actuators in. Although I could unscrew this whole top assembly, it's going to be much easier just to take these off, but eventually they'll be solvent welded on, or I could develop some sort of clip so they can come on and off. But I'm pretty happy with the look of that. They're pretty much in proportion. Obviously there's more pieces to go on, but it gives me an idea of the scale. Pretty happy with the way that's come out. I'm pretty happy with the size of it as well. So it was intended to be 20 to 30% bigger than a person. Not quite sure about that. It's a lot broader than I am, and it's probably going to be a little taller with its head on. So I think I've probably achieved that just through trial and error, or at least just through chance, I guess. But there we go. That's why it's worth putting these pieces on and fleshing it out in CAD to get the scale before trying to build it as I go. So next time I'm going to be working on the arms, I think, the upper arms, which have got a rotational piece in. And have a look at that part 3 to find out why that is. That's quite an important episode. After that, I can put the series elastic actuators into those 3 main shoulder joints that I'll have by then. And then we can start with some motion control and of course some more cosmetics. I'll also hopefully have the head servos so I can put a head platform on. Then we can really see what this thing's going to be like in motion. So don't forget to subscribe to my channel to check out more updates on this project and other projects. And also check out the social media links in the descriptions of this video.